Okay, this video is going to be over the Pythagorean theorem. It is found on page 181 of your textbook. You will take a minute to turn there. I'm going to be doing a little bit of geometry. I'm going to be talking about right triangles. Think for a moment what qualities you know are true of a right triangle. Has to have a right angle. An angle that will equal 90 degrees. That is true that you have a triangle that has an angle of 90 degrees and is a right triangle. Then what we talk about tonight, actually for you tonight, maybe tomorrow, daytime, is going to be true for every right triangle. So let's get some parts of the right triangle that we know. We know it has a right angle. We know it's going to have a hypotenuse. This is the hypotenuse. It is the longest side, and it's always opposite the right angle. Each of the other sides of the triangle are known as legs. That is a leg, and this is a leg. Okay? That's going to be important because as we talk about the Pythagorean theorem, we're going to find that the sum of the square of the legs is equal to the square of the hypotenuse. I'll get to that in a moment, because that is the Pythagorean theorem. Okay? So let's take a minute to look at the Pythagorean theorem. It's at the bottom of page 181. Notice we have a right triangle, and its legs are A and B, and the hypotenuse is C. So the Pythagorean theorem says that if I square one leg, or A squared, plus the square of the second leg, or B squared, will equal the square of the hypotenuse, or C squared. Recall, squaring a number is taking like A times A plus B times B will equal C times C. Okay? Let's put this into practice. Example 1. What if I give you a right triangle? This is on page 182. What if I give you a right triangle and I tell you that it has leg lengths of 10 centimeters and 24 centimeters? Let's label those. 10 centimeters and 24 centimeters. Okay? We need to find the length of the hypotenuse. Right. Well, we know that it's a right triangle because it has a right angle. So we can take a leg, 10, and square it. We take another leg, 24, and square it, and that will give us C squared. Okay? I need to know the squares of these numbers. We know that 10 squared is 100. This is why I said it would be helpful to know some of your squares. 24 squared is 576. Therefore, C squared is going to equal the sum of those, which is 676. Now, we need to find the inverse of squaring a number. Yesterday we talked about the inverse of squaring the number was the square root. So the square root of 676. We can do that on our calculator. When you find the square root of 676, you find that Mr. Height is 26 centimeters. Okay? That's just plugging information in, substituting your leg lengths to find the hypotenuse. What if I'm given this information? Uh-oh, something's different. A leg is A, a leg is B, and the hypotenuse is C. Well, let's remember the theorem. A squared plus B squared will equal C squared. Because I have a right triangle, it has a right angle. A squared is one of my lengths. I know it's 6, so 6 squared plus. Do I know my second leg? No, so let's leave it B squared equals C squared. Do I know height? Yes, 10 squared. Okay, let's go ahead and square these numbers. 6 squared is 36 plus B squared will equal, what's 10 squared? 100. This is just a simple two-step equation here. I want to find out B, so I need to get B squared by itself. So I'm going to subtract 36 because 36 was positive. Do the same thing on both sides, as Justin likes to say. 100 minus 36 is 64. So B squared is 64. Is that what I want to find? So is the leg length 64 centimeters? Nathan says no. What do I need to do? I need to do the inverse of squaring. I need to take the square root of 64, which we found out is positive or negative 8. But since I'm talking about a length here, I'm looking for the positive answer. So the length of leg 2 is 8 centimeters. Many things we can do using the Pythagorean theorem. Okay, that covered example 1, using the Pythagorean theorem. Let's look at some real-world applications to this. Many people find fire trucks very interesting, especially when you have the ladder truck. If you look at the picture on page 182, look at the picture as I read to you this information. A fire truck is parked next to a building. The base of the ladder is 16 feet away from the building. The fire truck is extending its ladder 30 feet up into the air, and it's leaning up against the building. So the distance, looking at the picture, the distance the ladder is from the truck is from the building, 16 feet, and the height that it is extended, 30, form the leg and the hypotenuse of a right triangle. Because as the truck is parked next to the building and then the truck form a right angle. Do you see how that is formed? Do you see how we could use the Pythagorean theorem? I have a leg length of 16, so I'm going to square it. Plus a leg length I don't know, which is going to be B squared. I know the hypotenuse, which is 30, and I'm going to square that. Now that we've substituted these in, 16 squared, if you had that memorized, you would know that that is 256, plus B squared equals, what's 30 squared? If you had that memorized, you would know that it is 900. So now I have the equation 256 plus B squared equals 900. As we continue to move on, using this 16 squared plus B squared equals 30 squared. We have 256 plus B squared equals 900. You solve from there and find out what B squared is. Once you do, see if the answer that you get is in close proximity to the answer they got on page 182 in example 2. I want to talk about next some if-then statements, conditional statements. I want you to look at the top of page 183. And it's talking about if-then statements. If-then. We're going to look at the horse example. It says, if an animal is a horse. So if we have a horse, then it has 4 legs. Is that true? If we have a horse, then it has 4 legs. Yes, a horse has 4 legs. If we have conditional statements, then we should be able to flip that statement and say the other part, taking the then statement and making it the if statement. And it would read something like this. If an animal has 4 legs, then it is a horse. Is that true? Silly Mrs. Rice. No, it's not true. We can think of many other animals other than a horse that has 4 legs. So sometimes we will find a converse and it won't be true. But other times we have a statement and it will be true. For example, if an angle is 90 degrees, then it is a right angle. That is true, right? If I have an angle that measures 90 degrees, it is then a right angle. Can I say the converse of that? Can I say that if an angle is a right angle, then it is 90 degrees. Is that true? Absolutely. It's true. If an angle is a right angle, it will be 90 degrees. Those same conditional statements can be said when we're talking about the Pythagorean theorem. If a triangle has side lengths A, B, and C, where A squared plus B squared will equal C squared, then the triangle is a right triangle with a hypotenuse of length C. So, will these measurements make up a right triangle? If it is a right triangle, then this has to be true. So the longest side is the hypotenuse. So that means that would be 25. So that means 7 squared plus 24 squared should equal 25 squared. Let's try. 7 squared we know is 49 plus 24 squared is 576. And does that equal 25 squared, which is 625? 576 plus 49 does in fact equal 625. So these, indeed, those 3 measurements would be the 2 legs and the hypotenuse of a right triangle. Because of the Pythagorean theorem, they can be used to substitute into the Pythagorean theorem. Let's try this one. If 16, 30, and 34 are the legs and the hypotenuse of a right triangle, then 16 squared plus 30 squared will equal 34 squared. 16 squared is 256, plus 30 squared we know is 900, and 34 squared is 1156. Is 900 plus 256 is 1156, and that does equal 1156, so it checks, and those also form a right triangle. Check out example 4. Look into some physics and see how the Pythagorean theorem can be applied when you're talking about two forces that are pulling at each other with a right angle. Mrs. Little would be so thrilled that we are using science and math together. Have a good rest of your day. Goodbye, everyone.